again. Welcome once more to Leopard Street. Welcome to the cellar. Welcome to a new t-shirt. This is from my wife's mother and father. Thank you, Faye and David. I like these. So, yes. Yeah. Anyway. Electrofrog points. What are they? How do they work? They're not that scary. How do you get one ready to install? Let's have a look. Well, as you can see, since the last videos, I've done a bit more track laying. I now have twin track all the way around to up here. It's still not powered. It still needs soldering to its PCB sleepers, all that's coming. All I've got to now is this point. Now this is currently straight out of the packet. I've added some fish plates to it and I've stuck it down just so I can try rolling some stock through it and see what it looks like. And it's fine. This is a Pico medium radius left-hand Electrofrog point. We'll have a look at exactly what that means in a minute, but it's not installed yet. It's not glued down. The holes under it aren't drilled. As you notice, the board lifts slightly, but it'll be sorted out once it's got some point work on it. I've got the plastic strips I need to put down over here ready to support the rails. There's going to be more points where those coaches are set. But today's job is this one. So what I'm going to do is I'm going to take this point out, we're going to get at the desk and we'll have a little look at what one of these things is. Okay, here we are. So here's the point, here's the packaging it comes in. Scary yellow packaging. Electrofrog with a little dynamic swoosh on it. Yeah. Okay, so what is an Electrofrog point? Well, there are two types of point. So if we start with this one here, and if I start off and say up here, I'll call this one Insulated. Well, what does that mean? This bit here tends to be called the frog, or the common crossing, depending on where you are, because it's where both tracks cross over each other. And in an Insulated point, let me just get a suitable colour. What you've got is a rail doing that, a rail doing that, rail that comes in there, rail that comes in there, one that goes down there, one that goes off there, and then here, that little bit in the middle, which I shall draw in green, hopefully this pink is showing up, is plastic. So what happens, you come along and you say, that rail's blue, so that rail will have blue power. That's brown, that's brown. And depending which way you switch the points, if say you switch them for the straight ahead route, this rail, this switch rail, which is this bit here, would do that, makes contact with this outer stock rail, picks up the electrical contact there as metal to metal, comes along here, and under this crossing there's a wire. So what you then get is that goes blue. And this one has nothing. So if you put your power feed at this end, and say this here are two sidings, loops, whatever, train can now drive down here. It's got power. And if there's a train in this siding, it won't go anywhere because it's got no power. And if you reverse the point, like that, now that one has no power. This rail here has made connection, and that goes blue. And all is good in the world. Because the rails here are either the correct polarity or they are not powered. But this little bit in the middle, and it varies in length. If you've looked on a typical Hornby point, it'll be about that sort of length there. Pico ones, it's a little bit smaller, which can bring its own problems. Basically, the rails get very close together. If you've got wide wheels, they can short out on some of the areas. But Insulated, you won't have the issue. Because if we're in this situation here, this rail, this switch rail here and this rail are not powered. So if the train runs over here and it catches one of them, it doesn't matter. That's an Insulated point. But you've obviously got a little bit, about an inch, maybe a bit less than that, where there's no power because it's plastic. This is why 040 locos, small 060 shunting engines don't like Insulated points. Your two wheels will come along, right, this one's no longer making contact. If it wobbles slightly, this one won't be making contact either, and your train will stop. And this is why sometimes you have to run small locomotives quite quickly over points so that the weight of the thing will just carry it on. That's an Insulated point. Okay, so what about an Electrofrog? Please ignore my utterly illegible handwriting. Right, here what we've got, very similar, but I can draw it slightly differently. Here we've got that. Now the key thing to note is there's no isolating section there. This is now all metal, which is what I've got on this point. So here, again, we connect blue and the outer rails will always be powered. This is assuming we're powering it from this end, the toe of the point, I believe it's called. And we're in this position again. We want to go straight. Well, that rail is now powered, but so is that. And all of this section here is now powered, including this rail, which, as you can see, goes quite close. This can be a problem if you've got older stock with wider wheels, because if it catches that rail when it's on there, it'll short circuit. There's ways around that, but that's the principle. And then you go like this, and then these bits here go blue instead of brown. Now, if you were to just fit this onto a normal layout for a siding, exactly like that, straight as it comes out the packet, it works fine. As long as you don't have stock with wide wheels, it'll work, because here we've got no power and power on one rail, and here we've got the same polarity on both rails. There's no potential difference. The locomotive won't move. This works on DC or DCC. You think, brilliant, but there's no dead spot. So apart from this issue with the wide wheels, you're fine here as well. Brilliant. So why don't we always use Electrofrog points? Well, we've talked about if you put the power feed at this end. What happens if you put it at this end? Say, for example, you've got... I'll do it in brown this time because it'll make life a little bit easier. Say, for example, you've got a loop. Now with the Insulated points, yeah, that works. That's fine, not a problem. So I'll just go back to my my colours. So over here we have a feed, and then the returns on this side. Doesn't really matter which is which, but there we go. So if these 2 points are set for the main line, this outer rail is powered and this inner rail isn't with DC. So if I put a train, I'll use this Orc's arm there. That's right, my youngest was down here building Warhammer figures. This line's powered, this line here isn't, train won't move. Flick them both that way, the loop is powered, the main line isn't. If you flick them one way or the other, what you'll get is both lines are now live, because you'd have power going through here, but it'll stop at this point, and this one power coming in, and it'll stop there. Not a problem. If you drive a train over that, it'll get a short circuit, but it'll also derail on the points, you don't want to do it. But if these are Electrofrog points, you now have a problem. If they're both set for the main line, no problems. If they're both set for the loop, no problems. The moment you do that, you've got a short circuit, because you've now connected this outer line to this side. And this is why the instructions, and it is quite clearly noted on here, about how to wire these with insulating rail joiners, state what you do when you're powering one of these up is you do that. And it's very simple. I mean, you could do this with DC or DCC, but what it means is you've now got to have another feed in the middle. But you can't feed power. And this is the rule with Electrofrog points. You can only feed power to the frog from one end. And it has to be the toe of the point. Can't be from over here. So, having said that, you will notice I've got metal rail joiners on here. It still matters, but what I've got on the board is I've got a board join there. So I'm going to have a little bit of track here and a little bit of track here. And I'm saying those bits of track I'm considering to be part of the frog. So they will switch with the frog. So I don't need more power feeds over here. And then there's a board join, which is the insulating join to the next section. And that's how one of these works out of the box. However, Pico allow you to modify them to be even more reliable. I mean, they are pretty reliable as they are, but I'd say you can have some issues here with wider wheels. You also have an issue that this is metal-to-metal contact for electrical switching. So the point is switching wheels. I can pick the thing up. I have a wheel here. So, ooh, look at this. We're switching wheels that go off that way and then derail because they're, yeah, anyway. But it's also switching the electrical current. And what this means is if these rails get dirty, you start getting poor reliability over the point. Now, if you've got an insulating joiner at this end, you'll have a power feed over here. So what you'll find is the unreliable bit is the bit in the middle. Pico have thought about that. Turn it over. There's a little wire, and it is a very little wire, very fine wire. Those who say you need to use massive wires for droppers on layouts, the size of that. Now, you don't want to use that over a long distance, but short distance, small wires work. And if you take that, what you can do, you can put a power feed into this bit in the middle. And you could leave the point exactly as it is and just wire that. So now what you've got is, if we come along here like this, I'll draw my point again. So what you've now got is your layout power feed there and there, but you've also got a single feed wire there. Green because it's a frog and therefore frogs are green. Easiest way of remembering that. Now, if you do that, you need some sort of switch to change the polarity of that contact. I'm sure you can see that here. Yeah, some sort of switch to change the polarity of that contact. Now, traditionally, what you do, and this is actually what is recommended on the back of the packet, you put one of the switches. Pico got PL13 or PL15 on the back of the point motor, and you wire that so that this is the common, and the two wires, other wires, come to the power feeds, and it will switch that bit for you. And if you do that, electrically, the point works in exactly the same way, except it's no longer picking up power. Well, it is, but it doesn't have to pick up power through the metal-to-metal contact here. You've actually put a power feed in the middle. And that works quite nicely. You can still get the issue with shorting out down here with wide wheels. So, in their infinite wisdom, there is a further modification. And again, this is on the back of the packet. This is nothing out of the ordinary. This isn't like some life hack. What you can do, if you look on the back, there's two little indents here. And in those, there's a tiny bridging wire. And on the top, the rails are cut. But by default, they're power bridged. Now, if you come into here, if you take those out, these switch rails are no longer powered by the frog feed. And the frog feed cannot now be powered by the switch rails. So you could do that. You've got your power feed here. And what you've just done is there are now isolating joins there. And you think, knockout. So now you're powering that separately. The switch rails are now back to being powered by metal-to-metal contact. But if the switch is in this position, the closed position, this switch rail here would be powered, and this one will have nothing in it. So if a wheel touches that, it doesn't matter. But you're back to metal-to-metal contact. Well, Pico thought about that. Now, unfortunately, this only applies to the 00 points. The N-gauge points don't have this, which is slightly frustrating. there's gaps in the sleepers here. What you can do is you can stick a wire there and a wire there, and that bonds the switch rails to the stock rail. And this is what I do on these points. Charlie over at Chadwick Model Railway does it. It's on the back of the packet as a suggestion. Away you go. And then this stock rail and this switch rail are always electrically the same, as are these two. Obviously the opposite side, in this case the brown feed and that's the blue feed. These outer rails continue to be powered and the Frog is switchable. What this means is every single bit of this rail is, assuming you get the switching right, this side, these rails are always the correct polarity. Doesn't matter which way this is set, they're the correct polarity. So if these wheels touch, doesn't matter. If you switch the Frog correctly, you can go through it. But now, the whole point is powered. Every single bit of rail on here is powered, apart from the check rails, but they're plastic, so we don't care about them. And we're not using the switch rails for electrical contact. So if a little bit of paint gets in there, or a bit of dirt gets in there, it doesn't matter. So what I'm going to do today, this is what I'm going to do in a minute, is I'm going to get the tools. Well, I've got some of the tools here. So what I'm going to do is I'm going to fish out these little bits of wire. Now they are quite fiddly to get at. They're not very big. And they are welded to the back of the rails, but only weakly. That's one that's cut up, so I'll get a cutter on that in a minute. I believe that's the other that's come up. So if I now get my cutters, which are around here somewhere, cutters in lieu of pliers, and what I'm going to do is pull these off. So there's one, the other cut and flew away. I'm just going to peel it out. There we are. So these two tiny little bits of wire here, I zoom you in and try and find them. There we go. These two tiny little bits of wire here have come out of these two holes. So yeah, that's that. So back to that. So get rid of those, they're rubbish, don't need them anymore. So now the Frog is not connected to these rails at all. And if I've got my meter to hand, which I have, I can show you this. And I've actually got another point which I can get out, which I haven't modified yet. I haven't started modifying, so we can see that as well in a minute. But here we are. So that there, contact. So that rail obviously connects there, is no longer connected to that, not connected to that. Switch the point. It is connected now because of the electrical continuity, but these bits here are not connected. So that is now isolated. Now if I grab the unmodified point, which is up here, I can show you the difference. I've got to modify them both, but I'm doing one at a time because I modify them as I fit them. So here is the unmodified version. So if I come to this now, and again, turn the meter back on, and again, that works. Points in this position, so that rail and the Frog are connected. It's connected to there. That bit and that bit are connected, but not to there. So that's that. It's fairly straightforward. I'm going to put this back in its packet so I remember which is the modified one and which is the unmodified one. Okay, so modifications. What are we going to do? Well, I need to strip two lengths of wire, which are going to go onto the back of here as feed wires. So I'm going to get the wires, and I'll be back in a sec. Okay, back with some wire. What I remember, there is something worth noting. This is a code 75 point. Everything I've said applies to the code 100 points as well. There is one massive difference between the two, which I think is wonderful. There's a spring in here. Now, I need to remove that because I'm going to be using servos. However, I'm not going to be powering the servos up for a while, so I don't want to remove it yet. Code 100 point, I'd have no choice because it comes off from the bottom. Code 75 comes off from the top, so I can lay this and I can remove that spring later. The other one, there is also now Unifrog points. Now, I've never used a Unifrog point, so don't quote me on this, but I think it's like this, but pre-modified, except the frog, instead of it being that size, is like that. It's small again. Same. It's basically an Insulated point where the frog has got its own feed wire. So you can not connect it and use it as an Insulated point, and it does all the power switching correctly. And I believe it's got these rails bonded electrically as well. Or you can do exactly the same thing, but power the frog as well, which is, I think that's a wonderful idea. I'm not using them because I started using Electrofrogs, and I'm going to continue with Electrofrogs, damn it. So the first thing I need to do is take this frog wire, and there's a little slot in the bottom of the point it fits into. And it comes up, and I need to shorten that because that's way too long. So I tend to shorten it to about where the point is. And what I now need to do is connect a green wire to that. So I'm going to strip the end of a green wire. I'm going to turn my soldering iron on because I'll need that. And here, a reasonable length of that. And I'm going to tin the end of this as usual. Which is, again, point out of the way while I'm doing this little blob of solder. And this, unlike the other wires, I leave this one straight because I'm going to have this wire coming out, and this is going to get a length of heat shrink put over it as well once the joint is secure. So do that there, and this is all just to protect it. So take that, take the soldering iron, a bit of solder, so, and come in against the side of that. Bit more solder into that. There we are, job done. I am, incidentally, loving this soldering iron. Now, slightly more awkward. What we're now going to do is solder that onto there, which is always a little bit difficult to do. So what I'm going to do, I'm actually going to trim that back slightly more. Basically, I just want the wire to be straight. That needs to sit upright. So there we are, that's a point sitting upright. Squeeze that against that, and I'm going to put a weight or something against the back of it there. So if I push against that, it doesn't move. And I need to bring this into here and solder them together. So I'm going to do that with a bit of solder on there. Bring the iron round here. Hold that to that to there, and do that. That's connected, and I'm just going to move my light around because I want to inspect that to see how good a join that is. And that is a rubbish join, so I'm going to redo that. Put that there, put that there again, and this is awkward, not so much because of the camera, but because of that weight. Well, I say weight, the paint pot. So a bit more solder on there, because I've got to bring this in from this side. More on there like that. Thought that was a better join then, but it's come off. Okay, right. this is going to be awkward. So what I'm going to do, there's another way of doing this, which I'm going to go back to, which is trim this again. I'm going to do it again. I'm going to wrap the two wires around each other. It's just the other way of doing it. I'd hoped not to have to, but it's a bit annoying. Put the camera back. It should be. Yeah, this basically needs to wrap around this now. And the easy way is like so. That goes through there. Wrap that round that. Then fold it along the wire like that. And that's so that when I do put the heat shrink over, it fits. So put that there, like so. Again, the wire so that it stays roughly where I want to put it. And then put a bit of flux on this, and then away we go. And this isn't perfect because the wire join is now wider than I'd like it to be. Just squeeze that down. And then come in with the soldering iron again. Should, with luck, be connected. It is, right. So, next step is getting some heat shrink over that. Move the light back out of the way. Tighten that back up again, it'll stay where it's put. Right, put a bit of heat shrink over this, which I'm hoping will slide over that. If it doesn't, I've got a slight problem, but never mind, I'll find a way. Yeah, that's going to go over there. You need to be a little bit careful because this wire is fairly fragile onto the base of the point. So if I do that, slide that on. There we go, heat shrink on there. I'm just going to shrink that a little bit with the iron. Doesn't need to be shrunk all that much. Really just enough to hold it on. Right, I now have a frog wire. Now the blue and the brown wires. And here, this is why it's worth doing these one at a time, rather than trying to say, I've got 20 odd points, so I'm going to have a session and I'm going to do all of these. What you need to do is make sure you get this the right way around. So this point is going, I think it's just knocked over. It's going this way round. So the brown wire is on the inside, which means the brown wire is on the outside from this side. So turn it this way round. And the way I'm going to do it, I'm going to tin the wires in a sec, is the wire goes in that way. And it can solder across both, and then the wire comes out in the middle. You could do it the other way around, have the wires come out at the outside. It doesn't matter. It just comes down to how you want to do it. I've seen them done, I think Charlie does it, so he has them both come in, meet in the middle, and then he can put the wires through a single hole. I prefer to put the wires through two separate holes. Yeah, just because the holes are smaller, and when I come to do ballast, there's less hole for the glue to flow through. But it's quite a minor point, if you'll excuse the pun. Right, so these now need tinning, so that wire, and this is obviously exactly the same as when you're laying track. It's just tinning the wires makes life a little bit simpler. I'm going to tin the point as well in a sec. Get rid of that yellow paint, because I don't need that anymore. Yeah. And then we're going to go here. Now, back with the layout, obviously these this area is not powered up yet. And it'll be a little while before it is. So I'm not going to be running trains over this under their own steam for a little while. It is going to happen, however. And that's sort of the whole point behind what I'm doing, so I can drive trains over all of this. what I'm going to do is I've got to build the board controllers. I need something to control the frog with. Now I use relays, and using a relay means you need something to drive the relay. So obviously I use ESP32 microcontrollers, use Arduinos. You could use a switch if it comes down to it. But first instance, what I'm going to have is when the layout powers up, that relay obviously won't be powered, so I can't switch it. What I can do, this particular point will normally be in the throne position. This is where the trains come in, this goes off the platform roads, this goes off to where the loco depot and such like's going, which doesn't exist yet, so there's no point trying to route trains to it. Just deal with that. The wires busy tangling around each other. Right, now I've got to tin the point, which is slightly more awkward to do. I'm going to bring my light back in here so I can see what I'm doing. But again, there's this little gap here. Now, something that is worth noting and is worth doing, there are some little stubs of sleeper just on the inside, little bits of the webbing. I find it's well worthwhile getting rid of them, because what you're doing is you're making this gap wider. And if it's wider, it's easier to get a soldering iron in, is my thinking. So that's what I'm going to do. I'm going to just shred that down there like so, and do these ones as well. One of the things I don't like about these points is the fact that you do have to come in and start shaving little bits of plastic here and there that really serve no purpose. So I just want to get rid of these, and just trying to make sure I'm not taking too much of the adjacent sleeper off with it, because otherwise it's just awkward to cut the plastic at that point, because you're cutting through more than you need to. So I'll do that one. There we go, and that one. There we are. And just shave those off, and then I could get a file in here and scrape it, but I'm just going to scratch the ends of that with my knife. Okay. That's now modified slightly, so I can come in with a bit of flux, and then I'm going to... And this is basically just doing a power feed. You're just doing it on 4 rails instead of doing it on 2. It's that simple. There's a bit of plastic in there I just want to get rid of, because if I don't, it's going to melt. And it'll melt. I don't have a problem with it melting. What I have a problem with is the fact if it melts, it'll stink. So, yeah. Right, start over here. That rail. That rail. Now, obviously, you are near plastic here, so you need to be a little bit careful. And a little bit quick. There we are. So brown rail is the stop rail there, so that is going to turn the point around. You do find once you've got a piece of wire stuck to these, they become remarkably awkward to work with. So what I'm now going to do, clean a bit of plastic that's melting on the end of the soldering iron off, bit of solder on there. Take the feed wire, which is naturally, because it coils, is tangling around itself. So this needs to come onto here. All of that in first, and then get in and same at that end. Which hasn't connected at that end, so I'm going to put a bit more solder on that. Yeah, this is why you do the little tug test, just to make sure. The awkward bit, basically what's happening is it's pressing down, and as it presses down, it's also pressing sideways, which is slightly annoying. So I'm just going to remelt those into little blobs. after a while you get to the point where you think, right, I'm just going to recut the wire and try again. So that goes onto there like that. That should be connected to both sides. Just need to... This is where the tug test fails. That'll do. But yeah, as I said, once you've got bits of wire stuck to this, it has an annoying habit of then getting in the way significantly. Wire, obviously, under the most carefully controlled of conditions, will do as it damn well pleases. So pick up this bit of solder and do the other rail. Now this is obviously taking a lot longer because I'm trying to film it and get it at a sensible angle. That side by the look of it. And that one, I hope. I'll try that, yeah. It's obviously taking a little bit longer because I'm trying to film it as well as I'm doing it. But hopefully that is working. Yeah, that's done. So what I'm now going to do is come in with the cutters, because if you see from the top you can see the bits of wire sticking out the sides. That's ugly, I don't like it. So I'm going to come in here and just trim that away, or try to. Like that. And this is really just so that when it's installed you can't see it. Yeah, this one's going to be a little bit more awkward. Try and get into here. Yes. Seems to have melted into the sleeper slightly. Only slightly, right. That's tidied up so it'll look a bit neater from the top. Obviously you can see the bits in the middle, they're going to get paint on them. Right, that's electrically, that is now modified to the layout. Okay, so here we are. Now, this is where it's going. Now I've marked out some holes already. I do need to move them very, very slightly, however, because the point isn't quite where it was supposed to be. So this hole here is going to be 10mm. This is where the actuator rods are going to come through. Now, I was watching a lovely video the other day. I forget who. And she cut basically a couple of holes, 3 in a row, put a file through it, slotted it. That worked really well, except I don't think I've got where I need these done quite that accurately. So I'm going with a bigger hole. And then I've got holes over here for the frog and whatever. So I'm going to get the drill. I'm going to drill these. This will be a 3mm hole. These will be 3mm holes. Then I'll swap out to the bigger bit for that. So I'm just going to get that done. This is a problem you do get with copy decks. It's strung itself round on the end of the drill bit, which is invariably a pain in the neck. So what I'm going to do is try that again. And yeah, it coils round on itself and takes the pulls a little bit of the rubbery glue out of the way. Right, I now need to get the bigger drill bit, which is around here somewhere. Aha! And find the drill bits. Sneaky drill bits, they hide from me. Don't blame them, really. So that can come into here. This is obviously a much bigger hole. You could drill a pilot hole first with this. To be honest, I don't really see the need. I'm only going through thin plywood. Again, make sure there's nothing under here that you care about before you do this. It's helpful not to push down too hard as well. because if you do, it will go all the way through. Right, that now needs cleaning, so quickly. And I shall come back round that side. Again, get my friend copied X. Now, the next bit is always awkward, which is threading the wires through the holes. Because invariably it seems, even though a drill bit went through there quite happily, there now isn't a hole, which is always a bit, I do wonder about that sometimes. Right, I need something I can poke through this hole just to find out where it's gone. That one needs the drill going through it again. I think what it's done is it's pulled the rubber over, which has obscured the hole. There's a couple of ways of dealing with it when that happens, but by far the easiest is to put the drill back through it. And again, just quickly. As you can see, that hole there made a bit of a mess. It's basically just ripped some of the cork up. Am I bothered by that? Not really. I mean, it does look a bit unsightly, but frankly, it's going to have a point sat over the top of it, so you're not really going to see it. So that's that one through there. Drag it out. Now that one through there. Drag that out. Like I say, these aren't actually going to get wired to anything just yet. Because the relay's not going to be far from the point underneath, but I haven't quite decided where it's all going yet. The plan, such as it is all of this stuff is going to get put in place. I am then going to lift all of this and work my way around it. So that needs to go through that hole. So I just need to slide into the fish plates over here, like so. And then the point gets a little bit of glue. It doesn't get much glue. Points don't need all that much. I do want some, because I'm using it to help hold the board in place. Avoid the tie bar area with glue, because, well, you can see what will happen if you glue the tie bar together. The point won't work. Right, that then gets pressed down into there as usual. Need to just pull that down slightly, check it's lined up, which it is. Do a very quick running test through the point. All I'm checking at this point really is this joint at this end. That works. That works. That now needs a weight going on it, for which I'm going to use a tin of paint. There we go. Okay, so that's a fairly simple little look at point work. We've got to look at Electrofrog points, what an Electrofrog and an Insulated is, how to wire them up. We will look at how to power them properly in another video when I get around to that. Like I say, all of this, I'm going to lay all of this track. There's another point going here, there's a double slip going here. We'll have a look at the double slip when I come to do that. Point track's coming down, it's going to come down Let's have a little look how far it's going to be. Well, the point will probably take it to about there. Probably about there in practice. There'll be another length, which is going to come to down here. Now, in theory, there's then going to be more going that way. However, I'm going to be stopping it here for now. The other bit may get, it'll get put in place, but it won't be glued down. I need to put some sensors in around here. Normally I use block detection. Now, in the station area, it's going to be a little bit simpler. All of this platform track is going to be a single block. Only the automation system needs to know if I'm driving a train in manually to do some shunting. To be honest, I don't care. I can do it by eye. But I need a way of stopping a train when it gets to this end. Now, elsewhere in the layout, I've used... the idea is I would put insulated join there. That bit will be another block. Train comes in. It's hit the block. Slow down. What if I'm reversing a train in? Which I will be on this road all the time, because the trains are going to get backed into here and be ready for departure. I need some sensors here. I'm probably going to use position sensors. Infrared ones, I'm going to have to experiment with them because I need to see whether they will pick up correctly the dark underside of a coach. If they don't, what I'm going to have to do, it's a fairly simple fix. What you do is you just paint a white bit under there, or put an RFID tag or something that's not black. But that's something I need to experiment with. But basically I'm going to get the two tracks laid along there. That'll give me the two platform roads with the point work. It won't be powered, not initially. Won't matter, I'll be able to drive trains in manually. There'll be enough of a relay. Just weighting that down flat. The relays will be set up so trains can run straight through. So I won't be able to swap tracks. Then we'll have a look at powering all that up. But I want to get all the track down, all the droppers in place, all the sleepers in place, it all soldered. So I've still got to do around there. It all cut. Then I can take the boards apart. Then I can put board controllers in. Then I can start routing where the cabling is going to go. I can add the point servos. I can add the point control boards. I can add the relays. I can add the relay controllers. It's all done then. Rather than, I want to do this point. Well, I couldn't have put these two down because I have to separate this. I have to get it all cut. Lift this board, wire this bit. But I'm going to come back and I'm going to have to do more here. That's the first bit. I'm probably, once I get past the point work, the track will go down really quickly. I'm probably also going to do the second double slip and another point here before I lift it to do the wiring. Just because I don't have to do it twice at that point. And that also means I can stick at least the two stub tracks and put a track over here that'll go off onto the turntable. It can all be wired up. So there we go. For the fans of manually driving trains, the block detection over here is simple. It's only the rails that are going to be automated, which is the two main line tracks and the platform roads. The depot, I was sort of I'm umming and ahhing as to whether it needs block detection. I don't think it does, because it's always going to be local control. It may get a couple of position sensors. So as we come over here, as we come up to where the, put a temporary bit of track here, as we come up to the turntable, somewhere like about there, there might be a position sensor around here somewhere. So basically if I'm down there driving trains, or I'm in the middle driving trains, I can just drive a train down here, and instead of having to visually guess how close it is, wait for the sensor to go ping and say, right, I will now stop the train, and I know it's short of the turntable before I can drive it on manually. I'm always going to have to drive onto the table manually because there's no way of knowing where they are. There's no sensors in the deck. In theory, I could probably fit some. It'd be awkward, and I don't really see the benefit, so I'm going to do that by hand. But that's it for this one. Yeah. Okay, so that's it for this episode. This one, we've had a look at this point. It's gone from being just laid here roughly to putting it in. We've had a little look at the differences between Insulated and Electrofrog. Electrofrogs give a little bit better running. I much prefer them. There are a few drawbacks. You have to consider how you're wiring things with loops and things. They're less suitable for what obviously is their train set layout that you're going to be setting up and breaking down constantly, because they do need more wire and power feeds. Not much more. It's not complicated. If you can wire a layout, you can run an Electrofrog point. They're not difficult. They just need a little bit more thought. But if you're using them for sidings, it only really matters with loops. If you're using that, if I put a ladder sidings on here, I wouldn't need to do any wiring. I could just literally just stuck them in. I'm doing it this way because I want the reliability. The thing that killed my N-gauge layout, which is all set track Insulated points, is the point continuity. Using the points to switch power didn't really work. They're old points, the rails are a bit dirty, the contacts aren't very good. Horrendous reliability issues. Same with the other points on the layout, which are all wired up in the same way. They're all large radius, whereas this is a medium, but they're all wired the same way. I've not had any electrical issues with the points. I'm not using them for power switching. That's all done with wires and relays. The switch blades don't do anything other than move the wheels, and so far they're moving the wheels quite happily. But that's it for this one. Next video, I'll have these bits of plastic painted, which I'm going to be doing shortly. I'm going to move on to the next point, which I will do off camera because it's exactly the same as this. It's just going to be sat here. Then we'll have a little look at the double slip, which is going to be interesting. It's the first double slip I have ever bought. I don't have pictures and I don't still have it, but I did build one many years ago, and to my absolute amazement, it worked. It was a bit ropey, but it worked. Well, I needed to build one because I had a straight track and a track curving across it. So that was fun, but it worked. But we've got the Pico Electrofrog one coming up, so we'll have a look at that. It's very, very similar. It's just got 4 feed wires on it already. And a bit like a diamond crossing, you put insulators on every rail coming in and out of the thing, and you just feed it and make it its own thing electrically, and then you don't have to worry about it. But that's coming up. Otherwise, thank you very much for that. Enjoy the rest of your week and your weekend, and I will catch you all in the next one. Thank you very much and goodbye.